common model of an atom shows the nucleus right here, and there are orbits around it. And the electrons, they'll follow these orbits very strictly, so that we'll know where an electron is. But now we know that electrons move much more unpredictably. Instead, electrons are found in areas called electron clouds. Another way to say electron cloud is orbital. And so there may be some electrons here and some here, and we don't know how they're moving, but we only know that these electrons will always be in this cloud, and these electrons will always be in this cloud. And what we do to find out which cloud an electron is in is we assign each electron a couple of numbers, and these numbers are called quantum numbers. Quantum numbers help us find how many electrons there are in an atom, and also which cloud they are in, or which orbital the electrons are in. The first quantum number is principal, and it is represented by the letter N. The principal quantum number shows the energy level that the electron is found in. And we can use numbers for the energy level. Whole numbers, 1, 2, 3, 4, and so on. The second quantum number is the angular momentum quantum number, or azimuthal quantum number. It is represented by the letter L. Either term is perfectly fine to use. And so this number tells us the shape of orbitals that are in the sublevel. So it tells us the sublevel. And we use the numbers 0, 1, 2, and 3. Each of these numbers represent a specific letter. 0 represents S, 1 represents P, 2 represents D, 3 represents F. And there are more shapes of orbitals, with like 4, 5, 6, but we don't need to know that for the introductory chemistry class. And so these all represent shapes of orbitals, like I said. The S, I'll only show you the S and the P orbital shapes. The S represents, or it looks like this. It looks like a sphere. And note that these are 3D models that I'm trying to draw. The P looks like this. And it's just like that. Some teachers may call it like a dumbbell. The third quantum number is the magnetic quantum number. It's represented by the letter M subscript L. The last quantum number we learned that in the S sublevel we have sphere-shaped orbitals, and in the P sublevel we have this shape orbitals. So we learned about the shapes of orbitals. Now with the magnetic quantum number, we'll learn how these orbitals are oriented in space. So we're going to talk about, or we're going to see what orbitals we want to talk about. And we use the range +3 all the way to -3. This is just the maximum range that we'll use for right now. But you don't have to go all the way to 3 for the range. You can go to +1 to -1, or +2 to -2, or just 0, depending on which sublevel you want to talk about. And so, how do we determine how many numbers we use? Well, we'll find out how many orientations there are. So for the S sublevel, it's a sphere, and we want to orient it differently in space. And so how do we think about that? Well, you just twist and turn it. Imagine it, a sphere twisting and turning. my hand's not a perfect sphere, but if you had a ball, if you twist and turn it like this, will it take up any more other space if you do that? No. It'll be oriented the same either way. So how about the p orbital? I'll use this marker as an example. We can twist and turn it, right? Wow, it's changing. It's taking up different space every single time I twist and turn it. Well, it can be oriented like this, or like this, or like this. This makes it so that in each p sublevel, there are 3 different orientations for the p orbitals. That means there are 3 orbitals in the p sublevel. And so each orientation correlates to a number. So the +1 could probably be like this, the 0 could probably be like this, and the -1 could probably be like this. Now, having more orbitals in the p sublevel means that there are more electrons. It's because each orbital can hold only 2 electrons. This orientation holds 2, this orientation holds 2, and this orientation holds 2 in one p sublevel, which means in one p sublevel there are 6 electrons that could possibly be in there. Now let's move on to the last and final quantum number. So with all the numbers that we have, we were slowly pinpointing where the electron is. Now we know which sublevel the electron is, we know what orbital the electron is in, and we know that orbitals only hold 2 electrons each. Now, how do we tell which electron we're looking at? We use the spin. And so the spin tells us how an electron spins, but more importantly, it tells us which specific electron we are looking at. And we use the letter m subscript s. The numbers we use are +1/2 and -1/2. So let's say we have an s orbital and a p orbital in an atom. So s is a sphere, p is like this, and there's 2 electrons in each orbital. And let's also have another p orbital like this. Okay, so we know we have 6 electrons, and they have to spin differently in each orbital. So this one will spin +1/2 and this one will spin -1/2. So now we know which electron we're talking about. And it could be either or. One of the electrons just has to be this and the other one just has to be that. And so for the p orbital, this could be +1/2, this could be -1/2, or vice versa, and same goes for these two. I just wanted to have a short little recap of all the quantum numbers that we've learned. The first quantum number is the principal quantum number, represented by the letter n, and it tells us which energy level we want to find an electron in. This is the broadest area where we can look for an electron. And each energy level is broken up into sublevels. And so the angular momentum quantum number, which is represented by the letter L, tells us how many sublevels there are in each energy level. But we still can't find the electron because we still have to open up more rooms in the sublevel. So each sublevel has a certain amount of orbitals that are oriented differently in space. That's what the magnetic quantum number is there for, which is represented by the letter m subscript L. It tells us the spatial orientation of each orbital in a sublevel. And so we know each orbital, it holds only 2 electrons. So which electron are we talking about? Well, we use the spin quantum number, represented by the letter m subscript s, to tell us which of the 2 electrons are we going to talk about in an orbital. And that is all the quantum numbers.